When you're dealing with high concurrency in Java, performance is king. Today, we're going to pop the hood on ConcurrentHashMap and really see the brilliant engineering that makes it such a powerhouse for multi-threaded programming. Let's dive in. So, to really get why this is so cool, you gotta look at what came before. Old school structures like Hashtable, they used one giant global lock. That means if a single thread was writing, every other thread just had to wait in line. It was like a one-lane highway during rush hour, a total bottleneck. Concurrent Hashtable, though, plays a completely different game. And the secret sauce here is a strategy called lock striping, or you might hear it called bucket-level locking. Honestly, this one architectural change changes everything. Instead of one big lock for the whole map, it uses lots of little ones. So what does that actually mean? Well, instead of one giant lock guarding all the data, the map is broken up into different partitions, or buckets, and each one of these buckets gets its very own lock. This allows different threads to work on different parts of the map without ever bothering each other. Okay, let's make this real. Imagine thread A needs to write a value into bucket 3. It just has to grab the lock for that specific bucket. The rest of the map? It's completely wide open and available for other threads. And this is where the magic really happens. At the exact same time, thread B can be writing to, say, bucket 7 by grabbing a totally different lock. There is zero interference between them. That's how you get true parallelism and incredible throughput. All right, so we've got the big picture, but how does this design actually affect the bread and butter operations? The reads and writes we do all the time. Well, let's start with reads, because they are fascinating. Get operations, just reading a value, are ridiculously fast because they're almost always lock-free. How? The map uses the volatile keyword on its node values. Think of volatile as a guarantee that any change made by one thread is instantly visible to all other threads. No locks, no waiting, just blazing fast access. Now, the put method is where things get really clever. The map is smart. It actually chooses between two different paths. If the bucket it needs to write to is empty, it zips down a super fast, lock-free path. If the bucket is already occupied, it falls back to a very quick, very targeted lock. That lock-free path uses a powerful technique called compare and swap, or CAS. This isn't your typical software lock. It's a low-level instruction, right down at the CPU level. It optimistically tries to put a new node into an empty slot. It's way, way faster than a traditional lock, which makes it absolutely perfect for these simple common insertions. But what happens when your keys aren't perfectly distributed? When a bunch of them end up in the exact same bucket. Well, this is where another piece of brilliant engineering kicks in. The magic number to remember is 8. As soon as a single bucket has more than 8 items piled up in it, the map says, whoa, this could become a performance problem, and it proactively transforms itself. See, at first, these collisions are just handled with a simple linked list. And for a few items, that's no big deal. But when that list starts to get long, finding what you're looking for means you might have to check every single item in the chain. Your search time becomes linear, O of n, and that can really slow things down. So the solution is something called treeification. That long, slow, linked list gets automatically converted into a much more efficient, self-balancing red-black tree. This is a total game changer. It improves the search performance from that slow, linear time to a highly efficient logarithmic time, O of log n. So when you put it all together, the lock striping, the smart CAS operations, the treeification, what's the actual payoff? What do we get in the real world? Let's sum up the key differences. This table just lays it all out. Yeah, both Hashtable and ConcurrentHashMap are thread-safe, but their internal machinery is from different planets. Hashtable's massive global lock is a performance killer, while ConcurrentHashMap's fine-grained intelligent locking delivers just unbelievably better performance in any multi-threaded scenario. So the bottom line is this. In the average case, when your keys are nicely spread out, you're getting constant time performance, O of 1, for both reads and writes. I mean, for a thread-safe structure, that is just phenomenal. And here's the beautiful part. Even in the worst-case scenario, when a ton of keys collide in one bucket, the performance is still fantastic. Thanks to that automatic treeification, the complexity only degrades to O of log n. It's a safety net that prevents things from ever grinding to a halt. So the real takeaway here isn't just to use ConcurrentHashMap, but to actually understand the principles behind it, things like fine-grained locking and optimistic techniques like CAS. It makes you wonder, right?
Where else in your own systems could these powerful ideas unlock a whole new level of performance?